Alright, so what we want to talk about now is how do we measure the accuracy of our classifier. Um, so remember that we were given a data set X, a target set T, and we built our classifier using let's say k equals 3. Okay, and now we say, okay, well, how does the classifier do? Well, what a lot of people do when they just start is they will actually use the data set that was used for the training in order to figure out what the error is. And do you see what the problem is for that? If we're now testing to see how well we do with X, right, our class labels will be always true. And so we'll have 100% accuracy, right? And so the key here is that whenever you're doing some kind of training on a classifier or a regression or whatever, the very first step that we always want to take, well, maybe I should say the very first step we should take when we're given data is to clean the data up. Scale it if necessary. And actually this pre-processing step right here can take a long time depending on what your data is like. There's data sets that have missing values. They have a bunch of outliers. It could be bad. So cleaning the data is really a key step. So secondly, what you want to do before you train your classifier is you want to split the data into training and testing sets. And the idea behind the testing set is you're going to be reserve this for the error computation at the very end. Okay, so you need to treat your testing set you don't even want to look at your testing set. You just want to take your testing set and reserve it somewhere. Don't look at it. You want to reserve it till the very end so you can estimate the true error of your algorithm. Okay. And so now what we do, by the way, usually, if a rule of thumb is 70% of your data for training, 30% for testing. But of course, that's a rule of thumb. It really depends on how much data you have. Yeah. So let's see what we're going to do now. So at this point, I could say, okay, I've split up my training, and I've got my training done. I developed my model for k equals 3, and now should I come over here and use my test set? Well, the problem is that if you're trying to figure out how many neighbors to use, you may actually want to use this data more than just to find the classifier for k equals 3. In fact, it would be nice to see what the error looks like if we use k equals 3, then k equals 4, then k equals 5, and so on. And then you could try to find find k with the lowest error. But what's the trouble with using this test set? The trouble is that you never touch the test set until the very end. You never touch the test set until the very end. And so what we need to do then is, instead of just treating this like a single set, we're going to, well, there's a couple ways that we can deal with this. One way to deal with this is we can split the training set into training and validation. Okay, and so the validation set now takes the place of like your intermediate error function. So you would use this set, the validation set, to test on your case. Now let's see how this works as a setup. So I've got my training set, I've got my validation set, and I build my model for k equals 3. I use the validation error. K equals 4. In fact, I could even do k equals 2. I could get the validation error and so on, right? And then my question would be, which k works best? Okay, so this is actually not too bad of a method, but the problem is that we've split the training set into training and validation just randomly, right? By the way, it would probably be, you would take this full set as your new set, and so this would be 70% of the 70%. This would, oh, you can't see where I'm pointing. the training set you would use here would be like 70% of the 70%, and then the validation set would be the 30%. So you take your training and split it 70-30. Okay. All right, and then you would just test again to see which k is the best. Now, there is a little bit of a problem with this. This will probably work pretty well in most cases because the validation set is hopefully representative of your data, but we can't guarantee that. And so a better way to do this, instead of doing this, we're going to do something called cross-validation. And so what we're going to talk about now is k-fold. Oops, yeah, it's too bad that they both use the word k here, k nearest neighbor and k-fold. It's not the same value of k, by the way. K-fold cross-validation of model parameters. So in this case, right, nearest neighbor, I'm looking for best k. Best number of nearest neighbors is typically what you would be looking for. Although cross-validation works for any model parameter, right? We're just using it right now for number of nearest neighbors. Good. So the idea here is that we're going to take our set and we're going to break it up into more than just the two sets. We're going to break it up. In fact, let's do a specific example. Five-fold validation. So you can follow along here on page 121. And so we've already said that we're going to break our training sets into other classes. And so using five-fold validation, cross-validation, what we do is we break this into 5 sets. And of course I drew that too big. Okay, and so why do we subdivide into 5? By the way, these are randomly drawn. Random. Okay. The idea here is that you're going to run the algorithm several times, right? To estimate the error. We want to estimate the error. So this is like test 1, 2, test set 1, test set 2, 3, 4, 5. And so the way we run this is the first round we reserve this set and we use these 4 for training, and then in the next round we're going to reserve the second set for error and use the other 4 sets for training. And then in the next round, you get the idea? We're going to reserve the third set for error, and all the other sets for training, and so on. So in fivefold, we're going to get 5 of these, right? 1, 2, 3, 4, 5. Okay, and so what do we do then? So I've done this for like k equals some fixed number. The idea is that this fivefold cross-validation is giving me an accurate measure of my true error. It's giving me a good estimate of the true error in using this number of neighbors. Of course, I've got 5 errors, right? And so we use the average. I think Python likes to call this a score. Okay, and now we do the same thing. We start over again with a new k, and start over again with another k, and start over again with another k, right? And then we were able to use these estimates then to figure out how well our estimator is doing. So we're going to have a script file that's going to try to do this. You might notice some of the things that we need to do when we're doing this. It looks complicated, but it's not that bad. So what you want to do is split your data into 5 sets, right? And so you're always figuring out, you're basically permuting which set is going to be the error set and which set is going to be used for training. So as long as your code can figure out how to do that, everything else is pretty straightforward. And so we'll try to write some code that actually does this. I'll give you some ideas, but I think it's worthwhile to actually try to do this yourself. I'm going to let you do this in groups of 3. I think 3 people, no more than 3. I don't want to have the class in one group. But you can work in groups of 3. I'll set this up in the homework problems, but so the idea is that we're going to try to set up a script file in MATLAB or Python that does cross-validation to find the best number of neighbors in our k-nearest neighbor algorithm. Okay, now I should say Python has this built in, but I don't want you to use the built-in function. The point here is that the algorithm has to make a lot of choices, and it's important that you understand what the choices are. And so you really have to do that when you're actually coding this yourself. But I know that some of you don't have very much experience with coding, so that's why we'll go in groups of 3, and I think I will probably put up kind of a beginning template that you can use to start. Yeah, and we'll go from there. And then if you need help with some particular section or some particular part of the algorithm, you can ask. I'll give you some extra time for this. We'll set this due in a week. Alright, so that's going to be the main homework. We're also going to do a little bit more coding for this section, and that's going to be, we'll talk about that in the next video. Because now that we have our model, by the way, I should say, I didn't finish this up actually. Once you find the best k, what do? Well, now you go back and use this entire training set to build your model with this k, and finally at the very end, what are we going to do? We can now use this reserve set for testing and see what the error was like. Okay, and so now I've got this error on my classifier, and I need to visualize it somehow. And so that is the role of the confusion matrix, and that is the topic of the next video.